All right, hi guys. So I am making a video to help you with your IXL assignments. So this will be assignments X3, X4, X5, and X6 for this upcoming week. So hopefully this video helps you. Watch it before you do the assignments. And once again, ask questions at office hours if you're still confused. So let's get started. For X3, you're looking at angles. Mostly using the unit circle. So it'd be helpful to refer to a unit circle as I did here. So when it says, which of the following shows a 0-degree angle in standard position? Look at our unit circle. The starting point, that's 0 degrees. You know, this is 30 degrees, that's 60 degrees, 90 degrees. 45, then 60, then 90, obviously it's a perpendicular. So I just want to point out that you can see the given angle measures on the unit circle. So when it says, what is 0 degrees in standard position, I'll put the answers in green here. It's going to be this one because 0 degrees is just that first starting angle there. Let's just remember standard position is where on the unit circle, it's where follow the highlighter in red. Your initial ray is on the x-axis, the positive x-axis, and then your terminal ray, or the other part of your angle, is going to be somewhere else. So it'll be an angle like that, or it'll be down here, so it'll be this angle that you're talking about. Or it could be there, or there. But as long as your initial ray is on the x-axis. So that's what it means to be in standard position. Okay, so that is the answer for that one. Let's move on, look at a little bit trickier. I just wanted to make sure we know to refer to the unit circle for these. So 45-degree angle in standard position. So 45 degrees is halfway between 0 and 90, right? So that means we're going to be looking at this one right there. That angle is 45 degrees in standard position. Okay, a 390-degree angle. So let's use, instead of having a full unit circle here, I just have your axes, right? So let's just start at 0. Follow the green, that's 0. If I go this much, that's 90 degrees. This would be a 90-degree angle. But I'm looking for 390, okay? So I'm going to keep going. This is 180. A straight line is 180 degrees. If I were to keep going, here is 270, okay? Here is 360. So a full rotation around the unit circle is 360 degrees. So I already did like a full lap, but 390 is 30 degrees more. So I need to continue another 30 degrees. So that means my angle is going to end there. So if we look at my options, which one's the closest one? It's going to be, that is a 390-degree angle in standard position. Okay, this one's a little bit different. It has a negative angle. So what happens when you see a negative angle, that means you're going to go backwards. So you're still going to start, follow the red highlighter. You are still going to start there, but now you're going to count this way. So that means this is now negative 90 degrees, right? If I keep going, this is now negative 180 degrees. Keep going, negative 270 degrees. Okay, I need to get to 360 or negative 360. So I keep going negative direction, and then negative 360 is just your starting position again. So which one is that of my options here? It's kind of hard to tell, but it's going to be this one because it's this line right here. It's just your starting position. So I did a full rotation around the unit circle and landed back at my starting. Okay, now I'm almost done with X3. So negative 135 is going to be, let's see, I'm starting here, and I have to go this direction because it's negative. So This is 90. Okay, so I need to go more than 90. This is negative 180. Okay, so I only wanted to go negative 135. So it's going to be between the negative 90 and the negative 180. So this graph in the top right corner is going to be the correct one. So negative 135 is right there. Okay, we talked about this briefly before we were, put onto remote instruction. But you can measure angles with, two different measurements. You have degrees, and then radians. Remember that radians will have the little pi symbol, and that's how you know it's in radians. And then degrees has your little circle to the right, upper right corner of the number. You guys are all familiar with degrees. So 2 ways to measure. So we're doing the same thing here, but instead of measuring with degrees, they want you to measure in radians. So they say, which of the following shows a 3 pi over 2 radian angles? So you're going to want to refer to a unit circle for this one to see where 3 pi over 2 falls. So that's going to be, okay, I'm going to show in highlighter here. This is the 30-degree angle. Pi over 6 is the radian, the way to describe that angle in radians. That's the corresponding thing. So let's look for, what was the number I needed? 3 pi over 2. Where's 3 pi over 2? On my unit circle, it's down here. So it's at 270 degrees. It's the same thing as 3 pi over 2 radians. So the question says, which of the following shows that in standard position? Okay, well that means that my angle is going to be, there's my initial, here's 3 pi over 2. So it's going to be like that. So which one of these represents that with the green? It's going to be this one, because you have your green arrow there and a green arrow there. Okay, here's another radian example. So 11 pi over 6. So I'm going to want to look at my unit circle again to see where 11 pi over 6 is. So let's look at this one. I'm going to erase the lines I just drew. Okay, 11 pi over 6, where is it? So this is my initial, and then my terminal, oh, there's 11 pi over 6. So 330 degrees is the same thing as 11 pi over 6 radians. So what's that going to look like for this question? Well, we saw that the angle looked like this. Oops, one there, one there. So it'd be the upper left corner. Okay. Oh, now we have a negative radians here. So negative 3 pi over 4 radians. Let's see. So let's find 3 pi over 4 first in my unit circle. 3 pi over 4 is this one right there. So it's 135 degrees. And there's my initial. So this is the angle that I'm looking at. But it's negative. So that means I'm going to draw the negative one in blue. So that means that I went this way. So my starting is there. That's what the negative version of it would look like. Just going the same angle, but just going the opposite way. Oops. So that blue angle is the same thing as the red angle, but it was just the negative version of it. So negative 3 pi over 4, it looks like the blue one. So on my answers here, it's going to be this one, where I have this angle there, and then my initial on the x-axis. Okay. A negative pi. So if we look at the unit circle, pi is right there. So that's just like a 180-degree line. It's just the x-axis, you can think of it. So if I go positive pi, I'll show in red. So that's going to be this whole thing, right? But if I were to go negative pi, I'll show that in blue. Start at the same place, but you're going to go the opposite direction. It doesn't matter because it's halfway of 360 already. So negative pi or positive pi, same thing. That's one case where it's going to be symmetrical. So if I look down here, negative pi radian angles, it's just going to be that straight line like we just saw. So it's the pink line is just on the x-axis like that, because pi radians is over here. So your angle is actually just 180 degree angle, which is a straight line, which is why it doesn't look like a real angle, but it is. Okay, I think last one for this section. Okay, a 570 degree angle in standard position. So this is a little bit trickier. We know that one full rotation around the unit circle is 360 degrees. So that means I'm going to be going around the unit circle at least once. So let's see. So let's follow. Okay, so here's my initial or my starting. I go all the way once around the unit circle. So that's 360 degrees right there. I need to go, oops. I need to go 570 degrees. So how many more degrees is that? So now I'm going to count by 90s. So I just did 360. Okay, so now I'm going to be in red. Okay, so that was 360. This is 90 more, so plus 90 degrees to get to here. So 360 plus 90 is what? 450 degrees. Okay, so I'm at 450. I'm getting closer. Okay, now I do another 90 more to get to this part. So 450 plus 90, what does that equal? 540, very close. I wanted to get to what was it? 570. So at 540, I need to get to 570. So that's 30 more degrees. So it's 30 more degrees. So that means that my angle is going to be there. So even though the number is bigger than 360, that's okay. That just means you're going to go all the way around the unit circle once and then keep going until you get to whatever your number was. So that means that this bottom right box would be your correct answer there. Here, I'll go ahead and erase all of my numbers. So that's what 570 degrees would look like. Okay. Now we're going to be talking about quadrants. You guys are probably familiar with this. Let's see. So before we start, quadrant 1 is your upper right. So if we're just looking at, this is like your x-axis, right? And then here's your y-axis on a graph. The upper right corner is quadrant 1. The one upper left corner is quadrant 2. Bottom left is quadrant 3, and then bottom right is quadrant 4. So that's how we label them. So refer to this diagram if you need. But the question asks, if x is positive, greater than 0, and y is greater than 0, also positive, where is your point located? So if both numbers are positive, that means that you are going to be in quadrant 1. That means you're going to be up here. If x is positive and y is positive. So that means that your answer is quadrant 1. Okay, if x is negative and y equals 0, where is your point located? Well, if y is 0, I know that my point is going to be on the x-axis, because that means that there's no variability in height if y equals 0. So you're staying on the x-axis. So that's going to be my answer, on the x-axis. If the point xy is on the x-axis, which of the following must be true? Is x 0 or is y 0? Well, we just talked about that. Y is 0. Oops. Y is 0 if you're on the x-axis. Look at a graph if you don't believe me. Okay, in which quadrant does the terminal side of a 225 degree angle lie? Okay, so we're gonna have to pull in what we did for x3. So the terminal side, remember, if this is like my graph, the initial side is going to be on the x-axis there, and then your terminal side is the other side. So once you know which quadrant your terminal side is, if you have a 225 degree angle. So this would be a 90 degree angle. This would be a 180-degree angle. This would be, here, I'll mark these. So this is a 90-degree. That's 180 degrees. This is a 270-degree angle, like from here. This is 90. This is 180. That's a 270-degree angle. So 225 is between 180 and 270. So 225 is going to be somewhere in here, between 180 and 270. So that means what quadrant is that? That's 1, that's 2. This is quadrant 3, and that's 4. So we were in quadrant 3. So you can look at a unit circle, or you can make your own little diagram like I just did to help you with that, but it really helps me to draw it visual so I know what my angle actually looks like. Okay, which quadrant does the terminal side of a 300-degree angle lie? So I'm going to draw another little visual again because that helps me. So here's my axes, my x-axis, my y-axis. I start, here's my initial side of my angle. Okay, there's 90. Here's a 180-degree angle. Here's a 270-degree angle. And if I went all the way back around, that would be 360. But that's 270, this one's 360. I need to stop at 300, so I'm between. So 300 degrees is going to be between 270 and 360. So which quadrant is that? That is quadrant 4. Okay. Flying through these. In which quadrant does the terminal side of a negative 315-degree angle in standard position lie? Okay, so this is going to be the same thing. I'm going to draw my axes, but this time I'm going to go the opposite direction because it's the negative angle. So I start on my initial side, and now I'm going to go backwards. So that's 90. That's negative 90 degrees. This is negative 180 degrees. This is negative 270 degrees. So let's write that. This is negative 270 degrees. If I went all the way back around again like this, then that would be at negative 360 degrees. But I only need to go 315. So that's going to be between negative 270 and negative 360. So it's going to be somewhere in there. So which quadrant is that? That is my first quadrant. The screenshot was weird on this one, but you can still see where quadrant 1 should be. Okay. Which ray is the terminal side of a 90-degree angle in standard position? Okay, so let's draw my axes. I start here, my initial, my terminal side for a 90-degree angle. I know a 90-degree angle is this, right? So the terminal side is on my positive y-axis. Positive y-axis. It's on the axis and it's only on the part that's above 0, so it's positive. Feel free to pause also anytime if I'm going too fast. Feel free to do whatever. Which ray is the terminal side of a 900-degree angle? Okay, so obviously this number is bigger than 360, so it's a matter of how many full rotations around the circle do I go. So let's draw it out. Okay, so with my highlighter, here's my initial. If I go all the way around once, that's 360. Ooh. So I'm at 360. Okay, I'm gonna go all the way around again in a different color. So that's another 360 that I just went. So 360 plus 360 is 720 degrees. Okay, so I've already gone 720 degrees and I only need to go 900. So there's a difference of 180, right? Like 900 minus 720 equals 180. So that means I need to go 180 more and I'll be at 900. So just remember, I started there and I went around twice, and so I'm still just right here. I'm still on my positive x-axis because I just did 2 full rotations. But now I need to do 180 degrees more. So that's going to be 90. That's going to be 180. So that means my terminal side is on the negative x-axis. So that's going to be this answer right there. So if your angle number measure is bigger than 360, that means you're going to have more than one rotation. That's okay. You're just going to have to do some math like I did over here to see what your remaining angle side is going to be, angle measure. Okay, same thing, but now you're using radians instead of degrees for your angles. So in which quadrant does the terminal side of a 5 pi over 4 radian angle in center position lie? So let's first find 5 pi over 4. Where's 5 pi over 4? There it is. So that angle. There's 5 pi over 4 on my unit circle. Which quadrant is that in? That's 1, 2, 3, 4. So it's in quadrant 3. So you just have to find where that radian is on your unit circle. So I recommend using the unit circle. You can find it on the internet. Okay, 35 pi over 6. This one is tricky. You probably won't get to one this hard on your IXL because if you look, this was in like the 90s, and you guys don't have to go that far. But I'll show you how to do it anyways. 35 pi over 6. I'm gonna just do some mental math here. I know that 36 pi over 6 is the same thing as 6 pi. If I were to reduce that fraction, that would be 6 pi. One full rotation around the unit circle is 2 pi, because 2 pi equals 360 degrees. So we know that one full rotation is 360 degrees. In radians, that's equivalent to 2 pi. So if I had 6 pi, that would be 3 full rotations around the unit circle. My number is not quite 36 pi though. It's 35 pi over 6. So that means it doesn't quite get all the way around 3 times. So I'll draw a little thing. So here's my axes, right? So that means I went around once, twice, 3 times, but not quite 3 times. So that means my third trip, because it was 35 pi over 6 instead of 36 pi over 6, my third trip was like, oh, and then cut short right there. So it means my last angle was there in my 4th quadrant. So my answer will be the 4th quadrant. That's a tricky one. We can talk about it more in office hours. Hopefully you don't have one that hard on your IXL. But yeah, there it is. Now we're going to move on to X5. Okay, so coterminal angles is a term you guys need to know. It means angles who share the same initial side and terminal side. So what we mean by that, so find the measure of a negative angle coterminal with 190 degrees. So you can, as we just saw, you can represent an angle as a positive or as a negative. So the coterminal angle is just going to be representing it as the opposite of what it was. So I could express 190 as, oh, it's positive 190, or it could also be negative 170 degrees. And I'll show you how we see that. So on my axes here. So a positive 190 degrees, that means I'm going this way. So that would be 90 degrees. This would be 180. So 190 is going to be like very close to 180, right? Just a little bit more than 180. So that angle in red right there, this is 190 degrees. Now, what if let's do this in blue. I could also get to that angle by going the opposite way, or the negative direction. So I could start here, follow the blue one, and I could go negative. I could go negative 90, And then to get to 190, that's 80 more. Yeah, I mean to get to 170, sorry. So that's negative 170 degrees in blue. Now to know if you did that right, those angles should add up to 360. Because I have in red, I have this is 190 degrees. And then if I did the same, if I stopped at the same spot, but I went the negative direction, that's 170 degrees. So to check that, you would add those numbers together to make sure you get 360. So 190 degrees plus 170 degrees, that gave me 360. Okay. So your the negative way to express that would be negative 170 degrees. It's the same thing as positive 190. Okay. Like a shortcut, if that was confusing, as I would just do 360 minus 190, and that will give me the 170. And I would just know that that needs to be negative 170. Once again, visuals help a lot. So if that's confusing, look at a unit circle. Okay, find the measure of a positive angle coterminal with negative 280. So they're giving us a negative angle this time. So here's my axes. Okay, so my initial is there. Going negative 280, that means I went this way. So that's negative 90. That's negative 180. That's negative 270. And it's a little bit more than that. So this whole thing is negative 280 degrees. Now the coterminal angle is going to be the same angle but expressed positively. So the coterminal angle I'm going to show in red is just going to be this angle right here. Like if I were just to start at my initial and then put that angle. So it's going to be, I'm going to know that both of those added together need to add to 360. So it's kind of like, okay, well, 280 degrees from the blue plus what number will give me 360? So you can do the subtraction right here. 360 minus 280 gives me 80 degrees. So that means I know that that spot is 80 degrees. So that would be the positive angle to represent negative 280. So the positive coterminal would be 80 degrees. So you see that they're the same angle, but I can express it as being a positive or a negative. Okay. Now we're going to be dealing with radians, but we're still talking about angles, so not too different. So find the measure of a positive angle coterminal with negative 5 pi over 4 radians. Okay, so first let's look at how much is 5 pi over 4 radians. So 5 pi over 4 is right here. So if I were to go like positive 5 pi over 4, it would be this angle in blue, right? That's how much I would go. I would go more than halfway around the unit circle. But now it says to go negative 5 pi over 4 radians. So that means I need to go the same distance, but the negative direction. So that means I start here and I need to go this way, 5 pi over 4. And that's where this red line is. So that's the same distance as 5 pi over 4, but I'm just going the opposite direction now. So I went past the halfway mark, and it actually ends up being the 3 pi over 4 angle. So the negative 5 pi over 4 is expressed in blue there. I could also express this as positive, right? So that would be I start at the my initial side on the x-axis, and then to end there, that would just be this angle in red. That would be the positive version of the angle. So I can see that that angle is 135 degrees, or it's just 3 pi over 4. The red angle is just 3 pi over 4. So I would write 3 pi over 4 radians. Two different ways to express the same angle. Okay. Find the measure of a negative angle coterminal with 80 degrees. Okay, so again, if I draw 80 degrees, so this is 90, right? And this is 0. So 80 degrees is going to be something like that. Okay, so the negative one, the negative version of this, show this in blue. That means I start here and I travel all this way around to find the negative version. So the simplest way to do that is, as I showed over here, just do 360, subtract the 80, and that will give you 280 degrees. So that means that you have to travel negative 280 degrees around this way to get the same angle. So the negative angle coterminal is negative 280 degrees, because that looks like the same thing as a positive 80 degrees. Okay, almost done with this one. Okay, so find the measures of a positive angle and a negative angle coterminal with 300 degrees. Okay, just for reference, let's see what 300 degrees looks like. Okay, start there. It's positive, so I go this way. That's 90, that's 180, that's 270. So 300 is going to be, you know, between 270 and 360, so it's going to be somewhere around there. So I could express this as a negative, right? The negative would be, I'll write it in red here, would be that much. So that would be negative 60 degrees. If I started here, I go 60 degrees in the negative direction, like this. That would leave me with the same angle. So my negative angle, would be negative 60, right? That's the same thing as positive 300 degrees. Another way to express a positive angle, this is kind of tricky because obviously 300 already is positive, but what if I went around, I'll erase these. What if I went around my circle more than once? So I start here, I travel around once, that's 360 degrees. Okay, now I go the 300. So now I go 90, 180, 270, 300. So I just did one, let's look over here. I did one full rotation around, so that's 360, and then did my 300. Oops. And that gives me 660. So 360 plus 300 gives me 660. So that would be another way of expressing 300 degrees. And there are infinitely many ways of expressing it. Let's say I wanted to go around the circle 5 times and then go around the 300 degrees. That would be technically the same angle as 300 degrees. You just have to do 360 times 5 and then add your 300. If that part confused you, don't worry about it. But there are infinitely many ways to express it. So another positive angle would be 660, as I just said. I just added 360 plus the 300 to get the same angle. Okay. Find the measure of a positive angle and a negative angle coterminal with 3 pi over 4 radians. Okay, same thing, but with radians this time. So let's first find 3 pi over 4 radians. Okay, so here's my initial. Let's make this a little bit smaller. And then 3 pi over 4 is right there. Okay, so this is my angle. So they want me to express this as another positive angle, and then also be able to express it negative. So let's go ahead and express it negative first. So the negative one I will show in blue. So that would be I start here and I go this direction. And that would be the same, it ends in the same spot, but I'm going to express like I'm going to express the angle as negative. So that means it's going to be 2 pi minus 3 pi over 4 will give me the negative angle. So how I would do this, 2 pi again, because that is one full rotation around the circle. So, but to be able to subtract this, I need to have common denominators, right? So 2 pi, I could also express that as 8 pi over 4 is the same thing as 2 pi, right? And I'm choosing 8 pi over 4 because I want the denominator to be 4. Okay, so 8 pi minus 3 pi equals 5 pi over 4. So that means that I have to go blue. I have to go negative 5 pi over 4 radians around to get to this angle right there. So that's negative 5 pi over 4. That's how to express it negatively. So negative 5 pi over 4 radians. And then the positive version of that, like I said, you could express it as I went around the circle once and then I went the angle that it says. So 3 pi over 4 radians is in red on the unit circle there. But I could go around the circle one whole time and then add 3 pi over 4. So going around the circle one full time is 2 pi, and then I can add my angle, which is 3 pi over 4. So to go ahead and do this math, again, I need to have common denominators. So I'm going to do 8 pi over 4, because that is the same thing as 2 pi. And I'm going to add 3 pi over 4. And this equals 11 pi over 4. So a positive way of expressing it would be 11 pi over 4. Pi over 4 radians. These ones get a little bit trickier, so I expect some questions in office hours about this. Okay, is this the last one? Yes, for this section. Okay. Find measures of a positive angle and a negative angle coterminal with negative 745 degrees and distinct from it. So, sorry, my brain just stopped working. Okay, I'm gonna draw it first. So negative 745 degrees, my initial, I'm going the negative direction. So 360 is one full rotation. If I do that again, that's 720. So I did the math over here. So that means, so 360 plus 360 is 720. So I can do 2 full rotations around the circle, and then I have 25 left over, because the difference between negative 720 and negative 745, the difference there is negative 25 degrees. Right, so that means that my actual angle looks something like that. It's like negative 25 degree angle after I went around twice. So another way to express this would be, like I just said, negative 25 degrees. The positive way to express this would be, I'll write it in red, would be I start here and then I go all the way around the circle and I end there. So it's going to be 360 degrees minus this 25 right there, and that will give you the rest of the angle. So 360 minus 25 degrees equals 335. So this little red spiral, that is 335 degrees in the positive direction. There we go. Okay. This video is getting kind of long. Last section though, X6, so reference angles. So a reference angle, the definition is the angle that the given angle makes with the x-axis. That sounds pretty confusing, but let me show you an example. So find the reference angle for a 100-degree angle. I like to think of it as what's the smallest angle that would bring me to the x-axis. So they say a 100-degree angle. So I wrote this in green already. I guess I can get rid of that one. So look at the green angle. That's 100 degrees, right? If I started here, ended there, this whole thing is 100 degrees. Now the reference angle is what's like the shortest way for me to get to the x-axis. Well, it's going to be, if you look at the blue, it's only 80 degrees away from the x-axis because this equals 180 degrees. This is 0, 90, 180, and then 270 is down here. So I'm only, if this is the green angle is 100 degrees, I'm only 80 degrees away from 180. And that's the shortest way for that angle to get back to the x-axis. So my reference angle is 80 degrees. Okay, let's do another one. Okay, for a 195-degree angle, let's draw it again. Okay, so 195-degree angle, we're starting here, this is 90, 180, so I'm going 15 degrees past my 180. So like, let's call this 195 degrees. Now, what's the shortest way for me to get back to the x-axis? Let me show you in red. It's going to be this little guy. That's the shortest way. The alternative would be this whole thing, but obviously that's way more than the first one that I showed you. So the fastest way to get back to the x-axis is that little red line. So once again, if this is 180 and the green angle shows 195, that means I'm only 15 degrees away from the x-axis. So I'm 15 degrees. That means that this little guy right here is 15 degrees. And that's the fastest way to get back to the x-axis. Okay, the measure of a reference angle for a negative 335. Okay, let's draw it. I'm a big fan of drawing all my angles. Visuals help a lot if you're getting confused. So my initial, I start there. This is negative 90, negative 180, negative 270. So negative 335 is going to be somewhere in there. Negative 335 degrees. So the fastest way for me to get back to the x-axis from there is going to be in blue. It's going to be this angle right here. So what's that angle going to be? It's basically, you can think of it as 360 minus my 335 degree angle will give me 25 degrees. So that means that this blue right there is 25 degrees. And that is my reference angle. It's the fastest way to get back to the x-axis. 25 degrees. Okay. Almost there, guys. Find the measure of the reference angle for a 655 degree angle. Okay, 655 degrees. I know that's going to go around my whole circle one whole time. To go around twice, it's going to require at least 720 degrees. And 655 is not that big, so I know it only goes around once and then most of the way a second time. So I just did some math over here. 655 minus 360 is 295. So like my remaining angle after I go around one whole time will be 295. So I'm just going to show the 295 part. So here's my circle. My initial was there. I went around 90, 180, 270, and then 295 is right there. It's in blue. So that whole thing is 295. What's the fastest way for me to get back to the x-axis? Well, it's that green line. So the x-axis, this is 360, right? Because one whole rotation around is 360. So if I'm at 295, it requires 65 more degrees to get back to 360, to get back to the x-axis. So my reference angle is, what did I say, 65 degrees. Okay, this one is harder. So this is a 1055 degree angle. Basically, I just want to know how many full rotations that is. So I divided 1055 degrees divided by 360 and I got 2.93. So that means that it goes around the unit circle 2 whole times and then some extra there. But for now, I'm just going to focus on the 2 whole times. So I do 360 times 2, and that gives me 720. So I already knew that. Going twice around the unit circle is 720 degrees. Now I need to know like the remainder though. So I'm going to do the degree it gave me minus the 720 from this number here. So I'm left with 335 degrees. So what this means is I went around the circle twice and then an extra 335 degrees. So 90, 180, 270, 330 is going to be like there. So that's going to be the angle that I end on. So that's what all that math kind of just showed me. So reference angle, what's the closest way for me to get to the x-axis from that point that I just showed you? Well, it's this little angle in blue. That's the shortest way to get back to the x-axis. 335, that is 25 degrees away from 360. So 360 minus that 335 gives me the 25 degrees. So this little angle there is only 25 degrees. So that means that's my reference. Okay, I'm gonna skip that one. Pause on this if you want to try it yourself. It's just the same thing we did the last time. I'm gonna get to the radians. So same concept, but with radians. So what's the reference angle for a 2 pi over 3 radian angle? So let's first find, I need to look at my unit circle, let's find where 2 pi over 3 is. Do we see it? Ah, there it is. So there's my initial, 2 pi over 3 is right there. So that means I'm talking about this angle here. Is it going to be quickest for me to get to the x-axis by this way or by that way? Obviously, the first way is the faster or shorter way to get to the x-axis. So I'm going to do what I need to find, like what this in red here is. I need to find what this distance is. So I know it's pi minus 2 pi over 3. How do I know that? Because this line is at pi. It says right there, that's pi. So pi minus that whole angle, so the whole angle is this thing, will give me this angle right here. So pi minus 2 pi over 3, that will give me my reference angle. Once again, to subtract fractions, I need to have a common denominator. So pi could be written as 3 pi over 3. I want a denominator of 3. So 3 pi over 3 minus 2 pi over 3, because that was my angle. And that will give me 1 pi over 3. So that means that in red, what I have over here, this difference is pi over 3. So I went 2 pi over 3 to get to this blue angle here, and then I went another pi over 3 to get to this line, which is the x-axis. So my reference angle would be pi over 3. Okay, that is it for now. Let's stop sharing. Once again, me and Mr. Rollins will both be at office hours this week. So I'd recommend watch this whole video before you try the IXL assignment, and then we'll be around to answer questions. I'm sure you'll still have questions even after watching the video. But hopefully this helps you guys, and we'll see you in office hours.